Welcome, everyone. Hi, everyone. Welcome to another episode of Scaling with Demi, where I talk about interesting tech stuff, scaling your startups, indexes, scaling your tech stack, auto scaling, load balancing. In this one, I'll be talking about idempotency. I'm talking about idempotency. And this is an interesting episode for me because, unlike the rest, this will be the first that I'll be hosting on my own personal channel. On the previous episode, we hosted on the company's channel, Pleasure's channel. But after a little bit of back and forth, they decided to let me go and host it on my own personal channel. So, yeah, welcome. And what is idempotency and why is it important? If you remember the last episode, I brought on a guest and we talked about auto-scaling your current jobs and some of the impacts of trying to auto-scale your current job, in which a lot of tasks are now done multiple times. A lot of tasks are duplicated. And this is fine for analytics and logs. I mean, all you have to lose is data and computing power. But when you are dealing with some financial systems, or when you are dealing with some systems that needs to run just once, right? You cannot afford it running twice. So you need to build your system in such a way that even if for whatever reason the system runs twice, the outcome should only be one. And I can give a very simple example of an idempotent system and a non-idempotent system, right? So you have a cake. If I say, look at the cake, that's an idempotent action. Looking at the cake is an idempotent action. No matter how much you look at the cake, nothing really changes in the cake, right? But if I say, eat the cake, right, that's a non-idempotent action because as you eat the cake reduces in size. So an idempotent action is an action that, irrespective of the amount of time the input comes in, provided it's that same input value, and same output is expected, right? So let me give a very good illustration. I register for Amazon and decided to buy a book. Yeah, I decided to buy a book in Amazon, right? If I buy this book, let's say the name of the book is Scaling with Demi. There's no book like that yet. Maybe one is coming along there. But if I buy a book called Scaling with Demi, it costs $100. And tomorrow I come again and buy that same book that costs $100, right? I'll be debited $200 in total, which means the system is not idempotent, which is not a bad thing. It's just by design, the system is not idempotent. But an example of an idempotent system would be if I'm to trigger a function that says, I want to lock my car, right? When I try to lock my car, I don't know, the cars I know about, right? When you try to lock your car, if the car is opened, it gets locked. If the car is locked, it gets locked. If I try to lock the car that I just locked, it gets locked. Nothing really changes, right? So the system always has the same output, right? So that's idempotent, right? Irrespective of the amount of input or the type of input that comes in, it's idempotent. And you would be thinking, why is this necessary when I'm building? I'm just writing code to my back end or my front end. Life is not that hard. Life is not that deep. Why do I have to care about this? But that's when you realize that, many financial infrastructures or many of the systems that exist, even non-financial, require the system to be idempotent. If not, there'll be chaos. So, for example, when you try to buy something and you get debited twice, it's probably because of some idempotency bug in the system that occurs. So let me give you an example of a system that would need idempotency designed into it, right? Very important. If not, it could cause a problem. So when a user signs, so I'm building a fintech service that allows you to probably transfer from Nigeria to Ghana or Algeria or some other countries. When a user signs up to my service, I want to update a particular third-party system about the user information, like MailChimp or Customer IO or some third-party integrations I can communicate with the user outside my backend code. So the first action is sign up. Then my backend says, okay, user signed up. Create user in CRM or some tool. Then I want to do some verification on the user. Let's say the user updates has to upload their bank account, their ID, maybe like their national ID or driver's license. So user uploads ID. Then I have to verify the ID using some third-party tool. Could be, there are a lot of third-party tools out there to verify the ID. So I need to verify that the ID is correct and mark it as verified or invalid. Then I need to update the CRM tool back and to say that, this user has been verified, right? So I can target users that are verified and users that are not verified for different messaging. So update user in CRM. And then let's say, because we are running a promo, so I want to credit the user with $5. The user that just signed up, they get $5 after the verification is complete. So I can put add $5 to account. I mean, so you can see this is a whole lot of process, right, that is going on just for user signing up on your application, on my application in this case, right? Now, I'm dealing with a lot of third-party systems. So many things can break. So many things can go wrong. I mean, if you've worked with a lot of APIs, you know that, I mean, you cannot rely on the APIs being uptime 24/7. You have to build a resilience into your code base, and you have to make it like kind of like idempotent and cater for risk conditions and a lot of all these edge cases. So one way you could do it is the user signs up, making a request. You try to run through each of these steps. In that request that the user has made, just a single request, right? You try to run through each of these steps, and when you're done, you return a response to the user that's validated. But you easily realize that this way does not work if you have any experience building softwares, right? You realize that, I mean, because each of these steps could take a really long time, and the user is going to be waiting for a response. You don't want the user to be waiting for many of these activities. They are potential asynchronous activities. So the other approach that might come to mind is, why don't I, when the user signs up, I take in the user details, right? Then I start processing each of these. But before I start processing it, I return a response to the user that, your details have been collected. And then I process all this. And at the end of the flow, I send the message to the user through their mail or their SMS or whatever that user validated successfully. Yeah, so that works. That's fine. That the kind of works. It works a lot of times. But what happens if, just to reiterate, the front end makes a request, it goes to the back end, I receive the details, I start processing on the operation. Before I even start processing on the operation, I send the response to the user that, I've received the information, I'm processing it, just hold on. And when I'm done, I send the request to the user back that, done processing. It seems perfect. We all live happily ever after. But no, it's very easy for you to now get into certain kind of problems, which is what happens if, as I made a request to sign up, I've already told the user I'm processing your request. But even though I've told the user I'm processing your request, and I start processing it, the API I'm using to process the ID or upload the ID, they have a downtime. That's messed up, right? Because now, in the third step, there's a failure. Boom, there's an error here, which means I cannot continue. And the user never gets validated. So how do I retry this logic? How do I retry this flow? Because the user is not making another action. The user has made a request. I will still the user to wait. And now there's an error in the flow. So how do I retry this whole action? And you might say, but Demi, I'll just have a cron job. We spoke about cron in the past, talk about the benefit of crons. I'll just build a cron job that will just pick up and retry all the tasks that has failed, right? So, and that's true. That's interesting. You're on track. But then if you create a cron job that says, I'm going to retry all this, and don't forget, it was in the verified ID that the user failed, that the transaction failed. When you want to retry it, when you want to retry the whole process, if you don't think about the idempotency in mind, what you do is that you pick it up from sign up again. So you have the user details stored somewhere in a cache or in the temporary database or someplace. You pick up the whole flow all over again. You attempt to sign up a user that's already been signed up because you're trying to retry the whole flow, the whole sign up flow. So you try to sign up a user that's already been signed up, right? And you say, this user already exists. Or if it doesn't say this user already exists, it creates a duplicate user. And then you are trying to create the user in the CRM, and the user already exists in the CRM. A previous user already exists in the CRM, so it creates another user in the CRM. And then you try to upload the ID again. And when you try to verify the ID, you realize that they're still down. There's still a downtime. Well, let me try again. And before you know it, they have 10 of the same users. That's if your system does not handle duplicates well. But you can see how this could easily become a problem. If your system can handle duplicates well, the first step will always fail because you'll be getting an error like, error signing up, user already exists, index already exists in database, email already exists. Depending on how you develop your system. So yeah, repeating the flow doesn't really work in this context. But there is a way you can actually develop a system like this to work. Now, no, this is an asynchronous system. If you have a different perspective, let me know how else you do it. Let me know in the comments, or you can add me in another way to do it. But one way to really do it is to take each of the tasks, right? So you want to take the smallest task among the whole flow, right? And create a method or create a process for each of them. You use a queue, and you have a cron that can trigger restart for each of the flow. So you take each of the flow, the smallest unit, the smallest part of the whole flow, and you isolate them and you run them independently. Now, there are other ways, there are a lot of ways you can make each of the flow even idempotent within themselves, and I'll try to touch on that. But then one way you can do is to say, oh, sign up. When the user makes a request to sign up, I have the sign up details of the user. I make a response, I reply to the user that, oh, we're already processing your data. Then I take the sign up details that the user provided, store it in, let's say, a database or somewhere. I persist the user, right, in database, like the user has signed up the record, but I mark it as, but I have a field that says, oh, has user been updated in CRM, which defaults to false, right? So this flow, all this flow does is takes in the sign up, creates the user in our local database, and it stops there. Like you don't do any other, that flow doesn't do any other thing, which is okay. So you now have another job that runs, that picks up all users in the database. I mean, this is another way to do it. There's a problem. I could foresee some other potential problem with this flow, but this is one way to do it, especially when you don't have a lot of records to query in the database. You now have another cron that picks up all users in database with updated in CRM or created in CRM, rather not updated in CRM, created in CRM. So you want to pick all users in database with created in CRM that as false, right? So all users, you can say, well, all users are registered yesterday or created in CRM is false. Then what you do with that is you make a request to create those users in the CRM and you update it to true once the request succeeds, right? But there's another field, let's say ID uploaded. I don't know, it could be anything, but let's say ID uploaded, false. Then after this, you run another flow, another cron job that picks all requests, all signups with created in CRM false, we created in CRM true, but uploaded ID as false, and that picks up. So it's each of this stage, a different cron picks them up and tries to execute them sequentially. I mean, so you could say, oh, this cron should be running every 2 minutes, every 3 minutes, depending on what you're trying to do. But then each of these stages, the cron picks them up. Now, this solves to some extent some of the problem with the duplicate data, because if there's a failure in a particular part, let's say in creating user in the CRM, there's a failure, this cron would not try to run any other one, and they will not try to run any of the previous one. The next time the cron is running, to be picking up this guy to rerun it. So that makes the system kind of resilient to some of the problems with errors in between. And this is very important if you are working with a lot of APIs, right? You end up having a lot of issues like this, whereby APIs are failing and you have to retry the logic, and you're thinking, how do I retry the logic? So you have to build it into your data architecture, right? Say, the system should be broken down it should be atomic as possible. And if there is an error in any part, the system should be able to recover from that error, right? So that kind of like to some extent solves the idea of idempotency to some extent. There are now some other things you can really think about, like inside your code, like say, oh, every flow should have a reference, a unique reference that is tied to the variables within that flow in itself. And whenever you're making a new request, you're trying to operate a new flow, you check if that reference already exists. And if that reference already exists, you know that, oh, this flow has already been executed. I'm not going to operate on that flow again. So in reality, you'd want to, because you can't depend on just cron you can, but there might be some limitations depending on just cron for your process to run. I mean, because right now, you will have to be doing a lot of queries, which could have some performance implication on your CPU and on your memory and your servers. You want to use a combination of both approach, right? So when the user makes a query the first time, you try to complete as many of the processes as possible, and each process triggers an enqueuing of the next process. So you would have broken everything down in an atomic step: the sign up, the upload ID, the verify ID, and when the user makes a request, you try to complete as many of those flows as possible. But then each step causes a trigger of the next step because the trigger of the next step, right? So that's the first step. So the user makes a request, each step causes a trigger of the next step because the trigger of the next step. And then if there's an error in one of the flows, one your cron jobs that picks up for each of the flows cannot pick up the Your current objective funnel we can now pick up the atomic unit that failed and we start the whole process just starting from that point. It's not starting from 1 to 10, but from 4 to 10 if it is the fourth flow that got an issue, right? So that's a very good way to now think of it, right? So you're not using the cron to manage your flow, while at the same time you're not just assuming you're going to retry all the logic. But then there could still be a question of, okay, what even within the atomic unit itself, what if there's a failure? How do I ensure idempotency? And that one you have to, which I kind of like mentioned earlier, and I said I was going to brush on it, is each of the atomic units, right? Each of the flows should have a reference attached, a generated reference, or like an ID. This could be an ID of the whole flow, or it could be an ID you somehow generated for that unique flow. And you develop it such, you design it such that that ID itself is dependent on the variables that is needed to run that flow, right? So when you're trying to run that flow, that unit with the same variable, it checks if that reference already exists, and if it exists, it knows that, oh, this flow has already been run before. Let's skip it to the next one. So you end up having a situation whereby you don't repeat, you don't have a lot of repeated requests or repeated flow. Now, one very personal experience I've had with using, I think I'll use one of my bank apps is when I try to make a transfer. So I'm trying to transfer 2,000 naira to someone, and there's an error at the final step, and I want to retry the transfer. I see the transfer has already, you've already made this transfer, even though the transfer failed. And this is because they are probably trying to be extra careful about some of these idempotent processes, some of these processes to avoid repetition. So what I end up doing is, instead of transferring 2,000, I transfer 2,001 naira. And it ends up going, and that's because I've changed the variable. And the reference that was generated initially, I'm pretty sure was generated based on the timestamp of my request, and in conjunction with the amount I'm trying to transfer. So changing one of those variables generated a different reference, and the system saw it as a unique transaction, a unique activity. So, I mean, there are other ways you can implement idempotency, but I'll be stopping here for this. The overarching thing is, when there are errors in your system and you want to retry, this could lead to problems with duplicate transactions, duplicate records, and you want to generate reference you want to divide your process into smaller units, first of all. You want to generate references for each of those units or for the general flow at once, and that reference should be unique and should not be repeated twice. And you want to design your system such that when there's an error in one of those flows, a cron can come up and pick it up from where it stops and continue the process. Thank you very much. I'm seeing you in the next episode. Don't forget to subscribe. And I'm currently, as a quick disclaimer, I'm currently taking a product management course on Demi.ng, where I talk about technologies for product managers. I explain what APIs are. I explain what some of the things that you don't really need to be a good product manager to know, but then they help you become better product managers. So the link to the course is in the description below. You can register for it and use my promo code Demi, and you get 10% off. See you there.